Bismillah ar-Rahman ar-Rahim. This is another example of the effect of heat on solids and liquids. He's asking if we have 100 grams of ice at 0 degrees C is mixed with 100 grams of water at 70 degrees C. What is the final temperature of the mixture? My son, this type of problems where the final temperature is not clear enough, you cannot simply say that heat gained equals heat lost or heat gained plus heat lost equals 0 will or might result in wrong answers, unlogic answer. So in order to answer this question, we need to make pre-judgment. You have to judge what will be the final situation first. Okay? We are not sure whether all of this ice will be melted, okay, or it might melt all the ice. Then we will end up with a final temperature which is between 0 and 70 degrees C. So before moving into answering the question, I have to make a pre-judgment. So how much heat is needed to melt all the ice? So heat needed to melt all ice, this will be the mass of ice multiplied by the latent heat of fusion. If you calculate this, this is 0.1, which is 100 grams, multiplied by 333,000, and this will be 33,300 joules. We need this much heat in order to melt all the ice. Okay. How much heat will the water lose by reducing the temperature from 70 degrees C to down to 0 degree C? So Q released from water by changing its temperature from 70 degrees C down to 0 degrees C. I'm talking about the heat lost, but the magnitude of that, the absolute value of this amount of heat. Okay, this will be mass of water, specific heat of water. Okay, the difference in temperature, which is 70. I'm taking the absolute value. Plugging the numbers, this will be 0.1 kilogram, specific heat 4186 joules per kilogram Kelvin. Multiplied by 70, and this will result in the following: 29,302 joules. As you can see, the amount of heat available or released from the water by decreasing its temperature from 70 to 0 degrees C, this is less than the amount of heat needed to melt all the ice. What can we conclude from this? So Q needed is less than the amount of heat available or released from water as its temperature decreases from 70 degrees C down to 0 degrees C. So what will be the conclusion? The conclusion that not all of ice will melt because we don't have enough heat to melt all the ice. To melt all the ice, we need 33,000 plus. But all what we have is just 29,000. Okay? So final temperature will be 0 with some of the ice melted. So it will be a mixture of ice and water. At what temperature? At 0 degrees C. Okay? So it will be 0 degrees C. If we ask one more, up to this point, we finished answering the question. Final temperature will be 0 degrees C, and it will be a mixture of ice and water at that 0 degrees C. Now I'll add one more question to understand the problem. If he asks to find how much ice is melted, how much ice melts. In this case, how much ice melts? Okay, so the amount of heat available in the water or released from the water will be absorbed by ice. So if I write Q gained by ice plus Q lost from water, this will be equal to 0. Okay, and the amount of heat gained by ice will be the mass of ice melted. Okay, it is not the 100 gram anymore. I am asking about how much ice melts. So the mass of ice melted multiplied by the latent heat of fusion, okay, plus that amount of heat which was released from water, which is 29,302. All of this is equal to 0. Of course, this will be minus because it is the heat lost. So the mass of ice melted will be 29302 divided by latent heat of fusion of ice is 333000, and this will give us the amount, which is 0.088 kilogram, or this is equal to 88 grams of ice melts. Okay, and what is remaining? We'll have 12 grams will be solid ice. Okay, so 88 gram is water, melted ice, and 12 gram will be solid ice. Let me elaborate even more and change the question now and say, rather than having 100 gram of water, we have 200 grams of water. Okay, so the same amount of ice at the same temperature. Okay, now I have 200 gram of water at 70 degrees C. What will be the final temperature? Okay, so let me do it on this side here. If instead we have 100 gram of ice at 0 degrees C mixed with or added to 200 grams of water at 70 degrees C. What do you think the effect will be? Of course, the amount of heat needed to melt all the ice we have calculated before. Okay, but now we would like to see how much heat can be released from the 200 grams of water by cooling down. So Q available, Q needed to melt ice. This didn't change, and we calculated before. It is 33,300 joules. The amount of heat released from water, as we call it, from 70 degrees C down to 0 degrees C, this can be calculated to be, it is the same as we calculated before. The only difference is we replace 0.1 with 0.2 because we have now 200 grams, not 100 grams of water. Okay, so it will be double that much. Okay, if you calculate that, this will be 0.2 for 186 multiplied by 70. If you do this calculation, you will get double that amount of heat, which is 58,604 joules. So we have more than enough. 58,000 is much greater than 33,000. So we are sure that all ice will melt. Okay, so conclusion, all ice will melt. Not only that, we have extra and more heat available. So final temperature will be greater than 0. So it will be enough to heat the ice above 0 degrees C, or the melted ice above 0 degrees C, of course, it will be less than the initial temperature of water, which was 70. So this is the final temperature. It should be somewhere between 0 degrees C and 70 degrees C. To find that one, that temperature, how much is the final temperature of this composite? Okay. Also, we will answer this question saying that Q gained by ice plus Q lost from water, this will be equal to 0. Of course, here this will be negative, this will be positive. Okay. Answer this question. The amount of heat gained by ice will be mass of ice multiplied by the latent heat of fusion, because all ice will get melted now, and this ice, its temperature will increase after being melted. So mass of ice multiplied by specific heat of water, because it is not ice anymore, it is now melted ice. Okay, so it is the mass of ice multiplied by the specific heat of water, because it has been melted, multiplied by T final minus T initial. So T final minus the initial temperature of the ice, which was 0 after being melted. Okay, so this is the amount of heat gained by ice. What about the amount of heat lost by water? So this will be plus mass of water multiplied by specific heat of water multiplied by T final minus T initial, which was 70. Okay, of course, T final will be less than 70, so this quantity will be negative. Okay, because T final is less than 70. This is equal to 0. All what you need now is to plug in the numbers. Mass of ice is 0.1 kilogram. Latent heat is 333,000. Mass of ice 0.1. Specific heat 4186 for water. T final is unknown. Mass of water is 200 grams, so I plug here 0.2. Specific heat of water is 4186. T final is unknown, and you solve for T final. If you do the calculations carefully, T final will turn out to be approximately 20 degrees C. As I told you, here T final is greater than 0 and less than 70, and 20 satisfies this question. In conclusion, my son, if you have such a problem where the final state of the composite is in doubt, you have to make the necessary judgment before going to the popular formula, which says heat gained by one component plus heat lost from the other component is equal to 0. With my best wishes. Thank you.